In this video, I want to take a look at the sample size for estimating population proportion. Here we are. Now, here's a formula. So in this video, first of all, I want to talk about where this formula came from, and then do one of the examples. So where did the formula come from? First of all, it came from this formula. We're going to copy this formula and we're going to solve it for n. Here is my formula. Margin of error is z of alpha over 2 multiplied by the square root of p hat q hat divided by n. So for short, I'm going to call margin of error just error. Okay, just for short. So now in order to get to n, I need to divide both sides by z of alpha over 2. So I'm going to have e divided by z of alpha over 2 equals the square root of p hat q hat over n. Now in order to get rid of the square root, I need to square both sides. That will give me e over z of alpha over 2 squared equals p hat q hat over n. Okay, now n is on the bottom. I want it on the top, so I'm gonna flip both sides of this equation. So I'm going to have z of alpha over 2 on the top, e in the denominator, squared. Now I changed the type of parentheses. It does not really matter what kind of parentheses we're using here. Okay, and now in order to solve for n, I need to multiply both sides by p hat times q hat. Right, so we have, what do we have? We have p hat q hat multiplied by z of alpha over 2 over e squared equals n. Okay, so this is our formula. Now, what is p hat and q hat? Now, if we know p hat from preliminary studies, let's say we had a pilot study and now we have an idea of p hat and q hat, fine, we can use them here. But if we don't, then we would have, we will assume that p hat is 0.5 or 50% and q hat is 50%. And actually that's the greatest the p hat multiplied by q hat will never be greater than 1/4 or 0.5 multiplied by 0.5. So it's just a given. So this product is also always going to be less than z of alpha over 2 divided by e squared multiplied by 1/4. So that's where we come up with a formula. Now we could also put 1/4 inside the square. So take a square root, put it inside, and that will give us a formula that you see. Now let's see how we're going to use this formula. Here's our example. Use the given data to find the minimum sample size required to estimate a population proportion or percentage. The margin of error, or E, is 0.050. The confidence level is 99%. That gives us alpha is 0.01. So in order to use a formula, we need the z-value. So the critical value that separates the top alpha of a 2.005. So let's see. Here's our normal distribution, and the value that separates the top 0.005 is 2.576. So the z-value is 2.576. Okay, let's put it into a formula. So our n is greater than 2.576 divided by E. Everything is squared. Oh, and E is multiplied by 2. We could multiply by 1/4 outside, or we could multiply by 2 inside the parentheses in the denominator. So I got 25.76 inside the parentheses. Now I'm gonna square it and convert it into a decimal form. And I got 663.5776. So, and remember, for your n, you're always gonna round your answer up to the nearest whole number. So my n is gonna be 664. Again, as a reminder, we're always rounding up. Even if it was 663.01, we would still round it to 664.